Hello, everyone. Uh, I was asked about my work as an artist, and I would like to first of all say that I do not necessarily consider myself to be an artist. I have been working on a computer science project for my graduate degree in Brown, and I was doing some algorithmic work. And the result of that was some work that had some artistic implications, but that was not my intention. So I just want to take you into the gallery of some images so that you understand what I mean by algorithmic imagery. This is from a gallery that was exhibited as part of the 2003 International Boston Cyber Arts Festival. And as you can see here, there are some images that have apparently nothing to do with mathematics or computer science, but they're the result of what is called a Hamiltonian process. And it is quite surprising to me that this was recognized as an artistic work, even though it was absolutely not my intention at all. So what I would like to do is I would like to quickly explain to you the thesis project that led to this and do a quick demonstration of the software. The work was in a field called the traveling salesman problem, and I wanted to create a dynamic environment to study this problem. First, some background on the traveling salesman problem. It's a famous open problem. Imagine you have a map on which you have a number of cities, and these cities, the traveling salesman would like to travel in order to sell his products. And what he would like to do is make a tour so that he comes back to where he started. When the number of cities is not too many, this is not a difficult problem to solve. You could just list all imaginable tours and choose the one with the minimum total distance. But as the number of cities increase, the number of potential tours to examine increases exponentially, and it becomes an incredibly difficult task. So what people have come up with are things called approximation algorithms, such as the nearest neighbor algorithm, farthest insertion algorithm, etc. But the problem itself is still open. It's called in the literature as the P equals NP problem. It's one of the millennium problems, and I believe there's still $1 million prize on it. It is an unexplained and unresolved problem, how to find the best possible tour. So I'm going to quickly take you to some of the features. It was created as an instruction tool for high school, college, and beyond. I'm going to quickly take you to some of the features here. You could create what I call equal permutation regions in the software, equal area regions, equal perimeter regions, and all of them come up with these incredible visual effects that I did not anticipate. And the more cities you're working with, the more exciting the image tends to be, with all kinds of symmetries or broken symmetries, etc. So here are some images from the gallery that I'm going to quickly show you, and I'm going to show you how it is done using the software. Alrighty, so let us quickly see how this is done on the software. So in Traveling Salesman Sketchpad, you're able to construct a number of nodes that you want to study. For simplicity, I'm just going to do 15 of these so we can see things better. And let us create a tour. And here you have some options. An exhaustive one for 15 even would take quite a while. So I'm just going to go with one of my favorites, the farthest insertion algorithm. And as you can see, imagine these are all cities that this tells you. For these cities, this is the closest, shortest tour that you can create using the farthest insertion algorithm. But imagine that one of the cities is movable. As you move the city around, you can see the tour update dynamically. So it's a dynamic environment. I'm going to declare one of these as the node of the probe for the isomorphism we're going to create. And let us color this node differently so we remember that this is the one that we're going to move. And what you could do is, for the region that I'm selecting right now, you can create an equal permutation region, okay? Or an equal perimeter region, equal area region. Let's go with the equal permutation region, resolution of 5 so we can see it quickly. As you notice, as you go from one color region into another, the tour dynamically updates, and that's why they're different colors. It indicates that every time you're in a particular colored region, there's a particular permutation, meaning order in which you traverse the tour. Let us increase this resolution to the highest possible. This will take 5 seconds. We are okay with that. And as the tour updates and the resolution updates, you can see you get a crisper image. Okay? And what you can do at this point is you can hide the nodes and the tour itself, and the resulting work has potential artistic value. It was not the intention of the work, but it is a happy byproduct. So this is an example of what I would call algorithmic imagery, a potentially new branch of visual arts and computer science, where you start studying an algorithmic process based on a scientific experiment, etc. And then the result is a happy visual arts construct that might have some artistic value. Alrighty, I hope you enjoyed it, and I hope to show you some more of the software in the future videos. Thank you.